So given two sets, A and B, which we can think of as events living in some sample space, we can find the union, find the intersection, and find the complement. But what if we have three or more sets? We can do something with that because anything you do once, you can do as many times as you need. We can form intersections and unions with multiple sets. However, we need to find the intersections and unions pairwise. And if we have both intersections and unions, we must specify the order using parentheses. Intersections and unions in parentheses should be found first. For example, if I have sets A, B, and C, then parentheses A intersect B, the whole thing union C. First I'll find A intersect B, those are the things that are in both, which will be just the element 2, but I'm going to take this set and union it with C, so that will be a set that includes all the elements that are in either this set containing 2 or the set C. And those elements are. Meanwhile, if I change where those parentheses are located, and so I have A intersect B union C, so I find B union C first, so that's everything in B together with everything in C without listing the duplicates. And then I can intersect that with A, and so the things that are in both A and this set 1, 2, 4, 6 are just going to be 1 and 2. What about an expression like A intersect B complement? So as a general rule, unary operations should be done before binary operations. In other words, if an operation acts on one input only, it should be done before any operations that act on two inputs. For example, if I take 3 plus square root 16, plus addition requires two inputs, whatever is being added. Meanwhile, square root only requires one input, whatever we're finding the square root of. So we'll find the square root of 16 first, and then add the result to 3. And since complement acts only on one thing, then we take care of complements first. For example, let our sample space be the numbers from 1 through 6, and we'll define two events. A is 1 through 5, and B is 1, 2, 3. The complement of A together with union, the complement of B. So I'll find the complement of A first. That's everything in our sample space that's not in A. And likewise, the complement of B, everything else. And our union will be. Now, as with everything else, parentheses reset the order of operations. And here's something to keep in mind. The complement bar is a grouping symbol. In other words, there's an implied set of parentheses at any time we use the complement bar over more than one set. So if we write this, that complement bar extends over the union of A and B. And so we should read this as A union B is inside a set of parentheses. So we'll figure those things out first, and then find the complement. Now, if we use our other notation, we would actually need to write out the parentheses explicitly. So, for example, let our sample space be, and we'll define two events, A, 1, 3, 5, and B, 1, 2, 3. So this complement of a union, again, because that complement bar extends over the union A, union B, we should regard A union B as being inside a set of parentheses. So we have to take care of it first. We form the set that consists of everything in A together with everything in B, but omit any duplicates. And then, now that we have a single set, we'll take the complement, everything that is not in 1, 2, 3, 5. And again, that's the rest of the sample space. Those are the elements 4 and 6. And it's worth noting that if we didn't extend the complement bar over the entire A union B, if it was complement A union complement B, then that would be the set. And the important thing here is noting that depending on how that complement bar is split up, we will end up with different sets.